Hi everyone, I'm Andrea. I'm gonna ask you one question. Does this image look familiar to you? Now, can you tell me what is it? Yes, you're right. It is a Cartesian system. Hmm, what about this one? Does this image looks familiar to you? Can you tell me what is it? Amazing! It is the X and Y axis. Now, does the pictures I showed you relate to our topic? Yes, our topic for today is correlation and scatter plot. Now, I will teach you as basic as I can for you to catch up. Let's go! Now, what is a scatter plot? Scatter plots are the graphs that present the relationship between two variables in a dataset. It represents data points on a two-dimensional plane or on a Cartesian system. The independent variable or attribute is plotted on the x-axis, while the dependent variable is plotted on the y-axis. These plots are often called scatter graphs or scatter diagrams. When to use scatter plot? When we have paired numerical data, when there are multiple values of dependent variable for a unique value of an independent variable, in determining the relationship between variables in some scenarios, such as identifying potential root causes of problems, checking whether two products that appear to be related both occur with the exact cause, and so on. Now, these are the examples of scatter plots. The line drawn in a scatter plot, which is near to almost all the points in the plot, is known as line of the best fit or the trend line. Now we have three types of correlation. We have positive correlation, negative correlation, and no correlation. For positive correlation, we have perfect positive correlation, high positive correlation, and low positive correlation. For the negative correlation, we have perfect negative correlation, high negative correlation, and low negative correlation. For no correlation, we have zero. Correlation coefficient. So before I teach you the correlation, this is our formula that you need to write down first. For our example, we have LCC Bacolod conducted a survey on college students to know if the number of hours of them studying affects their exam scores. They picked 10 students from different courses. So I have here data points written. For the X, we have the study hours, and for the Y, we have the scores. So now, we're about to write down the data points given. We have the x, the y, the x squared, the y squared, and the xy. So for the x, we will write down the data points given above. We have the 2, 1, 1, 3, 3, 2, 4, and 3, 2, 4. The data points given above the graph is identified as our x, so we will write down everything. Now we are going to write the data points given for the y. So we have 45, 26, 36, 67, 50, 54, 80, 31, 53, and 75. For our x squared, we're just going to multiply the data points given at the x by itself. And same goes to the y squared. So for the x squared, we have 4, 1, 1, 9, 4, 16, 9, 4, and 16. As I mentioned earlier, we are just going to multiply the y by itself. So we have 2025, 676, 900, 40401, 22500, 11664, 102400, 8649, 11,236, and 90,000. Now, for our xy, we are just going to multiply the data points given at the x and the y. For example, 2 times 45. So, after we write down everything, we are just gonna get the sum of each x, y, x squared, y squared, and xy. So for the sum of x, we have 25. Sum of y, we have 511. Sum of x squared, we have 73. Sum of y squared, we have 290,451. For the sum of xy, we have 1,424. So for our n, we are just gonna count how many data points are given. So we have 10 data points. So to solve this one and be able to get the correlation, we have to follow the formula given earlier. So for the denominator, we have to multiply the n to the sum of xy, and we have to multiply the sum of x and the sum of y. After that, we are going to multiply the n to the sum of x squared and multiply the... Now we are just gonna multiply the n to the sum of x squared and multiply the sum of x by itself. And same goes to the n multiplied to the sum of y squared and multiply the sum of y by itself. So after we write down everything, we are moving to the subtraction. So we are gonna subtract the 14,240 to 12,775. After we got the result, we are just gonna write it down. Open close bracket 105, open close bracket 644,289. So now what are we gonna do? We have to multiply the 105 to 644,289. So the sum of it was 67,650,345. After getting the sum, we are going to get the square root of 67,650,345. By getting the square root, we are going to have 8,224.98. So to get our results, we are gonna divide 1,465 to 8,224.98 and we will have 0.17. Therefore, it is identified as high positive correlation. And when we find it at the C table, we are gonna have 0.0675. So this is our correlation. So when we put the data points in a scatter plot, this would be the result. This shows high positive correlation.
It's easy, right? For sure you can catch up now. Correlation and scatter plots are powerful tools in real-life situations, helping identify relationships between variables. For example, in healthcare, they reveal links between exercise and health outcomes. Businesses use them to study sales trends against advertising. By visualizing data patterns, they aid in predictions, decision-making, and optimizing strategies efficiently. I hope you guys learned something in my discussion. Thank you for watching!